I hope we all had a wonderful break. Can you guys open to page 40? And while you're opening to page 40, just a couple of announcements that have nothing to do with this class. First, what is happening Thursday of next week here at GCC? Thursday of next week is advising day. What that means is that there are no day classes on Thursday. If you have a Thursday night class, you go to it. It is on as scheduled. But there are no day classes on Thursday, and the reason day classes are canceled is to give you guys a chance to meet with your academic advisor, come up with a good schedule, and pick from the whole variety of classes that we offer here in the fall. If you wait until the last minute to register, you're probably not going to get your first choice, and you might have a schedule that isn't ideal for you. So register early, I guess, is the summary of all that. But the first day you can register for the fall is this coming Thursday of next week. And next week, sort of in honor of that advising day, there's a first, something that I don't think has happened before here at GCC. It's called Open Classroom Week. If you go to the main GCC page and you click on that link right there, it will explain to you that next week you guys will have the chance to go visit a lot of different classes as you think about what you might want to take in the fall. So all that is written up here. You can take a look at it later. But here's a list of all the classes that are being offered at the moment. And so if you're thinking about maybe taking an accounting class next semester, you can take a look at the days, you can take a look at the times, you can take a look at the teachers. You can decide whether or not accounting might be something you would enjoy. You can decide whether or not Jeff Galbraith has a teaching style that kind of matches with your learning style. And so I think this is a really good opportunity to get some information about the different courses we offer and the different teachers that we have here, and make your decisions there. This happens every day of next week. Okay, Monday through Friday of next week is this open classroom thing. What's going to happen is on the outside of each of the classroom doors, there will be a little sign that says open or closed, and every teacher, when they start class, will flip that thing one way or the other. You can come up with a plan, a schedule that you can take a lot of classes next week and decide, or you can just kind of walk around and see what's open. Anyway, any questions on any of that? Okay, and one more advising day thing. On advising day, again, there are no classes, no day classes. And one thing that the business office is offering to you guys is a resume writing workshop. So if you want to create a resume from scratch, or if you want to polish up a resume that you already have, but you want to make it really shine, then you can do that Thursday of next week from 9 until 10. There are no classes, no day classes that day. So if you're free and you want to come on in, head over to the Hammond Business Studio, and Kathy will lead you through some techniques for developing a powerful and effective resume. Any questions on that? Okay, then we'll take a look at our calendar. Today, March the 19th, we cover something called piecewise defined functions. Can you guys raise your hand if you've heard of piecewise defined functions before? It's like some here and there, that's fine. And then Wednesday and Friday, you can see the topic is transformations. The fact that 2 days are spent on one topic gives you a sense of how important this topic is. And what happens after that? Monday of next week is our review day. Wednesday of next week is our second test. It will be here before you know it. Okay. And in terms of that second test, I'm going to do the same thing. Like you have a whole slew of review problems in the packet that we're working through. I'm going to make the videos. In fact, I might have already made the videos. I've made a lot of videos. I don't remember. But check out on YouTube. They're either there already or they will be there soon. Videos of me going through all the sample test problems for this test. Questions on the schedule? Okay. So all that behind us, let's do some math. So again, we're on page 40. We'll go up to the top. Sarah, number 1. Okay, so let's have a look at this this credit card statement, or part of one anyway. And there's all these different kinds of fees. There's a cash advance fee. Does everybody know what a cash advance is? Can somebody explain to us what a cash advance is? Okay, and how does that happen in a credit card? Like, do credit cards just give you money? It's kind of what a cash advance is, actually. Like if you just like go ring up some purchase And then you say, okay, but I want to take like another $20 or $100 more than that, kind of like a debit card works. But of course, you'll pay for it. You'll get the cash today, but you're going to pay that 3% fee in order to get that cash today. And then there's a transfer fee. So if you have a different credit card and you want to move your money from one credit card to another, sometimes they'll charge you a fee based on that. If you pay late, they'll really get you for that. So make sure you pay your credit card bill by the due date. And then over the credit limit, what does that mean? What is a credit limit? Yeah, so maybe you have like a limit of like $1,000 on a credit card. And if you go out and you buy some wonderful new TV for $1,500, well, they'll let you do it, but they'll charge you lots of extra money for it, okay? So you got to make sure you stay below that limit. So here's what we're going to do. We're going to analyze two of these things, the late payment fee, which is all of this, and the cash advance fee, which is just this first one here. So what I'd like to do is start with the late payment fee. Now, as we look at the late payment fee, actually, maybe we can get Tyler L. to read the late payment fee description. Okay, so if you make a late payment, they're going to charge you a fee. They might charge you a fee of $15 or $29 or $39. What determines which of those fees you're going to pay because you're late paying your credit card? It's how much is currently on your card. How much money do you currently owe? That's going to govern how much money they're going to charge you for not paying on time. So we've got three different rules here, and when we have different rules, we end up with something called a piecewise defined function. So here in purple is our piecewise defined function. Normally it's like f of x. I'm going to call this one L of x for our late payment fee. And it's got different pieces. And so we put a little curly brace to indicate that we're going to have a bunch of different things listed here. Now the first thing you put, all of these things that we're going to put here are the fees. What's the smallest fee you might pay? $15. So the very first thing I put up here is 15. But it's not always 15. It depends on how much money you owed. So we're going to let X represent the, what are we calling in here? The balance. X is the amount of money you currently owe. And when do you get charged that $15 fee? For what kind of balances? Yeah. So if X is trapped between 0 and $99.99, you pay 15 bucks. And mathematically, that's how we write if you owe between 0 and 99, you pay $15. There are two more rows to this function. Can you guys check with your neighbors and fill in those two rows? All right, I've got my three rows. Do you guys end up with the same kinds of things in yours? So, I mean, it looks like a lot of gobbledygook if you don't understand how to read it, but all it's saying is exactly what was in the paragraph up above. You pay different fees based on how much you owe. And we let X equal the balance, and you can see on the right-hand side, we've got all of these descriptors over here. If X is this kind of a number, then here's the rule. If X is this kind of a number, here's the different rule. And so this whole thing is called what kind of a function? That's a piecewise defined function because we have a bunch of pieces. That's what a piecewise defined function is. It's a function with more than one piece. We've seen functions like f of x is x squared plus 3. Even though there's a plus sign in there, that's one function. It's one rule. Doesn't matter what x is, you're plugging into that single rule. That's not a piecewise defined function. But here, you have different rules. One rule is 15, another one is 29, another is 39. Different rules depending on the x. Okay, so let's go down to the next one, the cash advance fee. Let me go to Taylor M.
Cash advance fee, 3% amount of cash advance, not less than $100.
Okay, so again, cash advance is where you say to the credit card company, hey, I could really use $100 right now, so give me $100 right now, and they will, but they'll charge you a fee for using their money when it's not really yours yet. So here's how they determine how much the fee is. They'll take 3% of the amount of the cash advance. So if I ask for $100, and you guys hold up the number of fingers that is the fee associated with $100, you're going to take 3% of whatever you want. I want $100. How many dollars are they going to ask for? Hold up the number of fingers. Number of fingers. Good. And if we're not exactly sure what we're doing, you take 3% of $100. 3% of 100 is 3. So if I ask for $100, they will charge me $3. They'll charge me the $100 too. I'll have to pay that back, but plus another 3. Michael? It would charge us 10. Okay, so let's do a different number. What if it's $200? You guys hold up the number of fingers. That is the fee for a $200 advance. So now we're doing 3% of 200, which is 6. So surprise, it doubled. But there's a catch here. And the catch is that the credit card company wants to make, they want to make significant amounts of money. And if we just ask for $100 or $200, they say, well, I'm only going to get $3. It's not really worth my while. So Michael makes this good observation. Michael, what would the charge be instead of $3? It would be $10. So there's a different rule over here to catch anybody who's just borrowing not that much money. So they're going to charge you 3% of whatever you borrow, but not less than $10. So if the right answer is $3, which it was for the first example, they're not going to charge you 3, they're going to charge you 10. If the right answer is $6, how much will they charge you? They'll charge you 10. If the answer is $11, how much will they charge you? They'll charge you 11. They don't go back to 10. They go up to 10, but they're not going down to 10. If the charge is $200 is the fee, how much will they charge you? $200. So let's see if we can figure out what this rule is. I'll write this one in blue. We need to know the amount of the cash advance. That's how much we borrow. That's going to be my X. So I'm going to have this cash advance fee, where X is the amount of the advance. How many different rules do we have here? How many pieces are there going to be in this function? There's going to be 2 pieces. If you don't borrow very much money, how much will the fee be? $10. If you do borrow a lot of money, then there's just this formula with the 3%. So 2 rules. Okay, so if, and then don't copy this because this is going to be not math at the moment, but if X is small, meaning you don't borrow very much, then how much will they charge you? Straight $10. If the fee is supposed to be a penny, they're going to charge you $10. But if X is big, that's where the 3% comes in. They're going to charge you 3% of what you borrowed, 3% of X. Mathematically, how do we write 3% of X? It's 0.03X. You buy that? That's 3% of X. As an example, if we were to borrow $200, that was one of our examples before. If you do 0.03 times 200, what did we say the fee was for $200? It was $6. So that's the $6. 0.03 times whatever you want for the advance. Okay, so then what's the part that we still have to clean up here? You like this formula? This is mathematically precise to you? Okay, Eric's got it exactly. What we're looking for is to clean up this x is small, x is big. There's some magical amount of money that you can borrow where the rules change. They're going to take 10 bucks for a while, but once you exceed a certain amount that you borrow, they're going to start with the 0.03x. So we got to find this magical number where the rules change. And Eric also gave us the way to find that number. Do you guys see how, like, we need to solve an equation. Can you write down the equation that you think we need to solve to find the magical x where the rules change? Michael? That's it. Eric, that's what you said, right? Yeah. You're finding the place where the fees are what? Where the two different fees are what? Where they're equal. And that's the magic spot where the rule is going to change. So we divide both sides by 0.03. What do we get? This is the magic place where the rules change. So let's see if we can't clean up this stuff we had put here before. Originally it said if x is small. How much is small? What's the magic number? So it's 333. If x is less than $333.33, they're going to charge you 10 bucks. Where does the other rule apply? That's right. Which rule are they going to apply if x is exactly $333.33? Top one? It'll be the same answer. I don't care which one they apply. How much are they going to charge you if you borrow $333.33? They're going to charge you 10 bucks. They could charge you 10 bucks in the first rule, or just as well, they could charge you 10 bucks in the second rule. 0.03 times how much we borrow. 333.33333. Yeah, close enough. So which one do you want to put it on? Doesn't matter. There. Again, what's the name of that kind of a function? Piecewise defined function. Two different pieces based on how much money you borrow, based on the value of the input. Questions on that? No, I don't think so. I think we just call it a piecewise. It is defined in terms of pieces. Good question. Okay, let's try two. We'll go to Tyler. Okay, so I want to look at a picture. What does that blue function right there really look like if I'm going to graph it? Okay, I've got two different pieces. Let's start with the top one because that's easier. Can you guys with your arm tell me what does y equals 10, because these are y's that we're looking at here. What does y equals 10 look like if you graph it? Can you show me with your arm? Y equals 10. Y equals 10. Yeah, I see lots of this. It is a horizontal line. So don't draw the whole thing, but if you put y equals 10 maybe right here, then that would say no matter how much money you take out for the advance, that's these numbers here, how much is charged? 10 bucks. You could take out $100 and it's 10. Take out 200 and it's 10. Take out 600 and it's 10. But it's not true, right? This doesn't work all the time. This only works for x is less than what number? 333. So you draw your horizontal line, but you got to cut it off. To cut it off at $333. So I'm going to erase all that stuff over there. Okay, that's my horizontal. All right, that's kind of poor. Let's try that again. All right, so horizontal line until we get to 333 bucks. And then the rules change. Now suppose we were to look at the second piece, which is a y equals 0.03x. And I really want to stress that the first things you see, this first column right here, these are y equals. It looks funny the way we write it. It's just how we use notation for piecewise defined functions, but it's y equals 10. It's y equals 0.03x. It's always y equals. Can you guys show me with your arm? Y equals 0.03x. What does that look like? Yeah, so this is it's a line, right? Because it looks like y equals mx plus b. And how much is the m for this example? 0.03, that's the slope. Slope of 0.03, it's positive. So is it uphill or downhill? So positive is uphill, but 0.03 is darn close to 0. So it's not uphill by very much, right? It's almost horizontal, but just enough of an incline. Plus b, how much is the b? Is nothing. The y-intercept of this is 0. That line goes through the origin. So we're going to graph that line. In order to graph a line, we just need 2 points. You can pick any 2 points that you want to. For example, let's see, I see 600 over here, so let's try 600. So if we go to the calculator and we put 600 in for the x, so we're doing 0.03 times 600, we get 18 bucks. All right, let's do 500 because 18 is off the graph. Good idea. Okay, so if we plug in 500, we get a fee of $15. So we'll put that over here. If x is 500, then 0.03 times 500 is $15. So that is the point, 500 comma 15, which we can plot. 515 is, oops, 515 is right there. And again, we need 2 points to plot a line. I can pick any other point that I want. The origin seems to make sense. What's the difficulty with connecting to the origin? It is a long way, but what's the problem with that? Yeah, part of this doesn't exist, right? That the bottom function only applies once you get big enough, once you're charging enough money or borrowing enough money. So let's not pick that one. What's the important number that we should pick? This is the 333. Like you really want to know what's happening when the rules change. So this is a given. Like you can pick 500 or 600 or 400. I don't care about the other point you pick, but definitely you want to pick the one where the rules change. So let's try plugging in the 333. Although some of you might be able to predict what's going to happen. If x is 333, then we take our 0.03 times x. What do we get? We get 10. What a surprise. That's where the rules changed. So this is the point 333, comma 10, which happens to be a point that's already there. Doesn't always work where they connect to each other, but these two do. And so if we come up here and we say this point is also on the graph, and then we've got a straight line and we just connect the dots. Questions on that? Okay. This is reasonable that piecewise defined functions come up in real life, right? I mean, like there's different rules based on what happens. Like you've seen credit card statements like this. There's a big old group activity that we'll get to once we do the next page, but here's another example. Generally, kids' prices are lower than adult prices, right? For like movie tickets, say. What's the input that determines how much you pay at the movies? Is your age. Maybe there's a group discount if you have a lot of people that you're bringing in. That would be another example. But your age, right? If you're below a certain age, you pay not too much. If you're above a certain age, you pay the maximum. But actually, if you get older, then what happens? Then it goes back down, right? So you can see the different rules. Just go to the movie theater. You will see a piecewise defined function. They won't write it as lovely as we write it here, but it's a piecewise function. Here's another example down here. Rental car, depending on how many miles you drive, like if they want to get a lot of money out of you, so they're going to charge you like a per mile thing. But if you don't drive enough, they don't make enough. So they're going to do some kind of minimum, just like the credit card was like a minimum $10 charge. That's an example. Over here, this is like a bulk discount type thing. If you have a lot of people going to the movies, they will charge you less money. So depending on how many people you have going, you have two different rules. An example where you have to deal with shipping costs. Generally, people want you to buy more stuff, so they might try to entice you by changing the shipping costs based on how much you buy. That makes sense? So based on how much you buy, you pay different kinds of shipping costs. Maybe if you buy enough, they'll give you free shipping. And then last example, income taxes. How are your income taxes determined? I know there's a lot of variables here, but what's the primary thing that decides how much money you pay when it comes to income tax time? You got to name one factor, the most important factor that decides how much money you owe on April 15th. It's your salary, right? How much money you made during the year is the primary factor. Now there's other factors too. In fact, the Internal Revenue Service hires thousands of people, and there's lots of people that make their profession doing taxes because it is so darn complicated, and like literally volumes like of stuff written about tax code. But ultimately, it's about your salary. The more you make, the more you pay. If you don't make very much, they'll give you like a low tax rate. But if you make a lot, they'll charge you a higher percentage. And so here's an example of that kind of thing. So I'm just pointing out that like piecewise defined functions happen everywhere. And so all we're doing is kind of giving them some grounding here in math. All right, let's go to the next page, which is 41. And we'll go to number 3. Katrina? Okay, so we saw that, all of that stuff we saw on the previous page. I'm sorry, is it Brian? Can you read number 4? Okay, let's pause right there. Absolute value function. You guys have seen this function. And next class, you're going to see it a whole bunch. But there's the absolute value function. What does the absolute value do to a number? Like in plain English? Makes it positive. What's the absolute value of 7? 7. It's positive already, doesn't do anything to it. What's the absolute value of negative 4? Positive 4. Negative makes it positive. Okay, turns out that's actually a piecewise defined function. If x is already bigger than or equal to 0, meaning it's already positive, what do you do to it when you take the absolute value? You do nothing, right? What was the absolute value of 7? 7. You didn't do anything to it. If it was x, it stays x. You don't change it. But if x is negative, if x is less than 0, you need to make it positive. Okay, mathematically, we can't write make x positive. Like it's not a rule. I heard a couple of people say something with negatives. Negative x. Let's see if this makes sense. Absolute value of negative 4. According to this rule, well, which one are we in? Top or bottom? In the bottom rule because the x is less than 0. And what we're supposed to do is negate the x. Negate the x. What is the negative of negative 4? 4. Does it do the right thing? Absolute value of negative 4 is positive 4? Yeah. It looks really strange because we're used to thinking absolute value just makes everything positive. So it's weird to see a negative in the front, but it's a negative there to cancel the negative that's already in the number. That's how you make it positive. All right, and there's the graph of the absolute value function. Let's go down to Michael for the ISD, right above B. Okay, here are some phrases that I think were defined in the reading. Certainly they're in the book. A constant function, again, you show me with your arm. What's the graph of y equals a constant, like y equals 10, we saw before? Horizontal. So if your graph consists of a bunch of horizontal little pieces, then we call it piecewise constant. Is this graph piecewise constant, a bunch of horizontal pieces? No. Is this graph at the bottom piecewise constant, a bunch of horizontal pieces? No, it's not all horizontal pieces. The next phrase that Michael read was piecewise linear. Linear things are allowed to have some kind of a slope. Could be uphill, could be downhill, could be horizontal. Is this absolute value piecewise linear where every piece is just a straight line? It is. So that's a piecewise linear function. How about this one down here? Is every piece of this graph a straight line? Yes, that is piecewise linear. But if you have a part of your graph which has any kind of a curve in it, it's not piecewise linear anymore. Okay, so absolute value you guys have a lot of experience with. Here's a function that I'm betting most of you have never seen before. Who's our reader now? We went here, Serge, B. Okay, so here's a new rule. Whatever x you give me, I'm going to find you the greatest integer less than or equal to x. And just like the absolute value symbols mean something to you, you know what to do with these funny vertical lines. You're about to know what to do with these funny, almost absolute value symbols. 3.1. It's not absolute value, and Serge read it the way that he dissociated it with the thing that's closest, but it's not the absolute value. It's, I guess you could say it's the greatest integer of 3.1. It's the greatest integer less than or equal to 3.1. So 3.1 goes down to what number? 3. The greatest integer less than or equal to 3.1 is 3. What's the greatest integer less than or equal to 3.99? Also 3. Is this the rounding function? Does it round the number and give you the round down? It's not a round, because 3.99, if we round, should easily get up to 4. This is not the rounding function. It's a completely different function. It goes down every time. Doesn't matter how close you are to going up, we go down. How about 4? What's the greatest integer less than or equal to 4? It is 4. 4 is the first number that makes it to 4. Can you guys fill in the blanks on these last two and check with your neighbors? Okay, 2.99. That one goes to 2. It's the last one that throws people for a loop. The greatest integer less than or equal to negative 0.4 is, I hear zeros, I hear negative ones. It's one of those. It's the greatest integer, and it's not either. We got it, it's only one. What's the greatest integer less than or equal to negative 0.4? Negative 1. 0 is bigger, right? We have to go down, always less. Negative 0.4 goes down to negative 1. All right, now what we're going to do is we're going to graph this really crazy function. You guys kind of have a table here. You might not realize it. The things inside the brackets are the x's. The things in red here are the y's. We're going to plot some points. Can you guys plot all those points? Okay, so we've got these points plotted up here. It already looks strange. Is it a straight line? I mean, it can't be, right? I mean, it just looks weird. It can't be a straight line. What does it look like? Well, let's see. I've got this point right here was the 3.1 goes to 3. 3.99 also goes to 3. How about every number between 3.1 and 3.99? What did they get rounded down to? 3. So every number in between, is it 3? How about 3 itself? What do you get when you round down 3? It's 3, so the point 33 is on the graph. Looking at the far right, what happens when we get to 4? It bounces up to 4. Is there a last number that I can plot here before it goes up to 4? There's no last one, right? Even if you were to say like, yeah, we're gonna put a hollow circle, because even if you say like 3.99999 goes to 3, I agree, but I can name another 9 at the end of that, and that's even bigger than the one you said. So you can't plot a last one. So the way you indicate get as close to this as you can, but it's not really here, is that open circle. So this open circle is at the point 3, nope, it's at the point 43. So that is one piece of this round down function. The next piece of the round down function is up there at 4. It goes all the way to the right until you get to what number? It's 5. Right there at 5 is where the rules change, and it bounces up again and walks to the right. So we've got all these different pieces, and so just draw a few more of these guys. And we see a graph that's certainly different than anything we've ever seen before, right? Yeah. So it's called the floor function because everything gets rounded down to the floor. It's also called a step function, which is kind of a graphical thing, right? Looks like a staircase. Okay, so that is good. And why do we, why do we care about this kind of a function, or is this just made up in math class to give you more stuff to do? Well, what if you had, what if you have like a cell phone plan, and you talk for 3 minutes and 40 seconds? For how many minutes will you probably get charged? Probably 4 minutes, right? If you have 3 minutes and 40 seconds, they're probably going to bump you up and charge you for 4 minutes. What if you have 3 minutes and 10 seconds? 3 minutes and 10 seconds? Will they generously give you those 10 seconds for free? You know they won't, right? They're going to charge you for 4 minutes if you talk for 3 minutes and 10 seconds. In fact, some of the most painful cell phone conversation I ever have, I hit the stop button, I look at the time, and it's like 7 minutes and 1 second. Because of course you're going to pay for 8 minutes, right? So, all right, is that this function where it rounds everything down? No, it rounds everything up. But you can see it's like exactly this, just push all these lines up by 1. So there are plenty of places where like we have to round someplace, and the businesses are going to make as much money as they can. They're going to round stuff up whenever they can. All right, we have 32 minutes, which may be enough time. There's a lot of group activity on these next few pages. So what I'd really like for you guys to do is work through all of the stuff on the following pages. There are 4 examples. Make sure you do all the stuff in the directions. Check with each other. Also, you should know there is an answer key. Don't look at it just yet because you don't want to look what the answers are. But there is an answer key that follows all of this if you get stuck. Also, there are flags. I will come around and help